Okay, so with the absolute values, the big thing again with the equations is you got to have two answers in most of the cases, and there's really just a couple of steps we have here. Again, the very first step is that we're going to get the absolute value symbols by themselves on one side of the equation. And that's always a step one of anything we do, whether it's equations or inequalities, it's always going to be that same thing that you're going to do. The rest of the steps, it's almost like when we were doing like the always, sometimes, never. This is more like a 2A, 2B, 2C kind of thing when you go through these. So on 2A, once you've got this by the absolute value by itself, here's the first thing you're going to look for. If you get to this point and you have the absolute value of whatever it is that we're doing, x plus, it doesn't really matter what's on the inside, but as long as you've got this absolute value by itself and it's equal to a negative number, then you get to stop right there. You're done, basically. Because if absolute value is equal to a negative number, your answer is no solution. Or they might give you a never true option, but basically you're done. Because if you remember with absolute value that it's a measure of distance, and when you're doing distance, you don't talk about negative numbers. It's 10 spaces to the right or it's 10 spaces left. If we talk about going to Bridge Street, it's 12 miles to Bridge Street. Doesn't matter if you're facing Bridge Street or your back is turned to Bridge Street. It's still, from this distance from here to Bridge Street, it's still 12 miles. Doesn't matter which way you're facing. We're measuring a straight line distance. So if you get the absolute value by itself and whatever you have here, if that's equal to a negative number, there's nothing else to do. You just say, all right, we're going to stop right there. The answer is no solution. Or it might even give the option of never true. All right, 2B, and this is where you're going to do most of the work because this is the most normal situations when you go through these. So if you have the absolute value of whatever it is that we're doing here, and it equals a positive number, then what you have to do is you're going to split this thing into two equations. Or two parts, two equations, whatever how you want to say it here, doesn't really matter. And when we're splitting into two parts, what you're going to do is you're going to take the inside of the square root. Sorry, take the inside of the absolute value. And set it equal to the positive number. And basically, here's our two things we're going to do. So, like an A part here, that A, you're going to set it to the positive number, and then B, you set it equal to the negative of that number. Okay, and you don't have to write this down, but just kind of thinking about it, that if we were doing this equation, if you're doing the absolute value of this equation, whatever it was that we were going to do, and it equaled 10, and if you remember anything about absolute values, if you take the absolute value of 10, that would equal 10. If you take the absolute value of negative 10, that would also equal 10. So if you've got the absolute value of something that's equal to 10, then you can either take the absolute value of 10 to get 10, or you can take the absolute value of negative 10 to get 10. So for that part of it, that's why we always kind of say, all right, well, if this inside number that we have here, we're just going to compare it kind of, the two different ways. So for this one, let's say we take just to give you an example. So we did absolute value of x plus 1 equals 14. Okay, so take the inside of the absolute value you have, let's take it out without any absolute values on it. Again, this number can either equal negative 14 or that can equal positive 14. Because if you put 14 in here, 14 equal 14. If you put the negative 14 in, take the absolute value of it, it's still equal to 14. And then once you split it in two parts, it's just a regular solving equation. Subtract 1, subtract 1. So x would equal negative 15, and then x would equal 13. And with Math Excel, the way they would set this one up is that, if we were solving an equation like this, we would just circle the two answers and have it done. With Math Excel, they're going to give you just x equals, and they're going to give you an empty box. And you just go back and write down all the answers that you have. If it was just negative 15, that would have been your one answer. But because we've got two, you just put a comma and then you put the next number there. And it's not order specific. It doesn't matter if you put the bigger number first or the smaller number second. It just, as long as you've got the correct two answers, any order is fine when you go through those answers. So it's not a specific order that you have to put those into. Okay, so let's give you let me show you 2C real quick. With 2C, the last little option on this one, and this is just a really quick one here. If you have the absolute value of whatever it is that you're working with and it equals 0, because there is no positive 0, there is no negative 0, 0 is just 0. So if you have the absolute value of whatever it is that you're working with equal to 0, you only get one solution. Okay, so let me give you, 2 or 3 examples on this one just so you can kind of see. And again, the directions will basically be just solve. Won't be anything else to it other than that. Sorry about that. So the absolute value of 2x plus 4, let's let that equal 20. Okay, so this one, it's already done. The first step, we've got it already set up because its absolute values by itself equal to 20. So from here, we can just go ahead and split this thing up into the 2 parts. So we can do 2x plus 4 equal to negative 20. And then 2x plus 4 equal to a positive 20. Okay. And then once you split it up, it's just regular solving equation. You just do it like you normally would do. Minus 4 on this side, minus 4 on this side. And as you're working through these, the steps will always be the exact same as you're showing the work on these. And then get to the end on this one, you'll divide both sides by 2. Okay. And again, if you're putting the answers on Math Excel, it would just be x equals, and then you got the box, negative 12, comma 8. Okay, so big thing is that once you split it up into the two parts, after that it's just a regular solving equation. There's not anything special or fancy about it. It's just knowing that, again, if you have absolute values, that you're always looking for two answers when you go through these. Okay, for example 2, let's crank it up, make it a little bit more lengthy on the setup of the problem. Okay, now let me kind of, as we're putting this problem up here, sometimes people will get this problem and they'll go, oh, this one's no solution because it equals a negative number. And I'm like, well, not exactly, because again, if you go back to this one, step 1 is you always have to get the absolute value by itself first. And then once you've got step 1 done, then you can go ahead and do the rest of them. So for this problem, it's the same thing, that before you do anything else, you've got to get this absolute value by itself, which means we're basically keeping this thing, we're keeping this part, we've got to get rid of this 2, we've got to get rid of this -7. And you can almost think about this as like being a big giant X over this thing, that it's 2 times the absolute value minus 7 equals 3. So it's almost like this is 2x minus 7 equals -3. That you could solve this just like a regular equation, just kind of covering up the absolute value part for a second. So first thing is you would do is go ahead and do the +7. Okay, and you've still got 2 times on this part, so then you can go back and divide both sides by 2. Okay, and now this is when you'll actually check it, because now you have the absolute value all by itself. We've got the absolute value of x plus 9 equals 2. It's positive, so for this one, we actually get to go ahead and solve this one out. If we got here and this answer was negative, then that's when we could stop. But for this problem, we have to get it down to here before we can check it. All right, and then we can split it up into 2 parts. So absolute value of x plus 9 could equal -2, or x plus 9 can equal +2. Okay. And only one step here on this one, we'll subtract 9 from both sides. So x would equal -11. And from this one, x would equal -7. And again, with Math Excel, they're going to give you a box with the x equals. And you just have to go back and put in those 2 answers with the comma in between.
Does it matter like the order?
No, order doesn't matter. So if it's -11 and -7, or you put -7, -11, order does not matter in this case. Okay, one more equation, and there's one other. After we do this one equation, there's one other thing we have to talk about. That's still with equations, but something a little bit different here. And let me see. I think I can get this in at the bottom of the page here. We'll try it. So let's go with 4 times the absolute value of 2x minus 5 plus 16 equals 6. Okay. And again, when you're solving this equation, you can kind of think about whatever the absolute value is as being like a big giant X. So you almost think about it like that. So it's 4x plus 15 equals 6. So this is, if it's 4x plus 15 equals 6, you just subtract 15 from both sides. All right, and then since it's 4 times this one, to get the by itself, we'll divide both sides by 4. And I'm running out of room here at the bottom, so I'm going to put this over on the side over here. So we've got the absolute value of 2x minus 5 equals -9/4. And there's probably 2 voices going off in your head. One of them's going, oh, it's a fraction. I hate working with fractions. But hopefully the other voice is saying, wait a minute, that's absolute value equal to a negative number. So it doesn't matter if it's a fraction or not. Once you get this, you just stop and you go, all right, no solution. And again, with Math Excel, I think the way they have it set up is that you'll have this X equals with the box in it, and then underneath that, they'll have another option where you click on it and it says no solution. So you just check the no solution part, and then you're good to go. Okay. Now, and honestly, what's going to happen is a lot of times is you're going to be solving a lot of these problems, and you're going to roll through it, and the negative one's going to sneak up on you, and you're going to solve it, and you're going to get to the end, and you're going to be like, but wait a minute, I got answers, and then you're going to miss it a couple times, and you're going to be like, oh yeah, it's a trick question. So that's the biggest thing I've seen people do is they get in such a habit of working it, they forget to check for that negative number, and then they'll just kind of realize that they made a simple mistake there. Right, now there's one last thing with equations. And this is one where I don't think y'all have heard this before. If you have, you can let me know. But I know this is one of those things that didn't pop up in geometry. I don't remember it really popping up in Algebra 1 way back when. Oops. Extraneous solutions. Anybody ever heard that word? Maybe not. Probably not. More than likely, probably not. If you haven't, then it's not a big deal. Basically, is this extraneous solutions. Whenever you see this, just realize that you must check your work. Because what an extraneous solution is that it's basically it's a solution that does not check with the original problem. So you get an answer, or you may get two. The way we're setting up problems because we're doing absolute value, you may get two answers, and then you go back and you actually check it, and it may not actually work on this thing. Best case scenario I can kind of give you on something like this was that same scenario I had when I had a professor in college talking about this. He said, what if I told you we could get rid of 99% of traffic fatalities? No, we don't have to bubble wrap cars. We don't have to, put extra guardrails up on the. He said it's just one simple change to some of the existing laws that's here. The government has to get involved. Would you be willing to do it? What do you think? Get rid of 99% traffic fatalities. You don't have to pay anything extra. No extra cost on anybody. Would you be willing to do it? Sound like a good idea? Sounds like a winner, right? Here's the one thing we're going to do different that we have to do to make it work out. Speed limit 15. Is that going to work? Could we function on a society at a speed limit of 15 miles an hour? Probably not, right? Because now you're talking about an hour to go to Bridge Street. If you want to go crazy, we'll give you 20 on the interstate. Now you want to go to the beach? It's 360 miles there at 20 miles an hour. Do a quick check on that. It takes you 18 hours to get to the coast now. And that's without, now you're probably not going to have to stop for gas because you're not going to be going very fast. That's if you're like me, I'm going to have to stop 2, maybe 3 times to get some food. So, if we just hit McDonald's on the drive-through or Burger King, now you're talking about 19 hours just to get there. So if you leave at 6 a.m., you might get there at midnight. And most people go, yeah, that's not going to work. Yeah, it's not going to work. So this is one of those things that it's a simple fix if we're looking at, making it so that cars are safer and the roads are safer. But at the same time, it's like that's just not something that's going to work, because the speed limit of 15 or 20 miles an hour, we're just not used to that, because it's just, it works, but it's an answer, but it's really not going to work when it comes off of that. It takes you an hour to get to Bridge Street. If you live 10 minutes from Sparkman, it's going to take you 45 minutes or so to get here. For me, it's kind of the same way. I'm about 12 or 15 miles, so it takes me maybe 15 minutes to get here in the morning. If traffic's good, maybe 20 minutes, a little bit longer. But if I do it now, it's going to take over an hour to get here. Okay, so extraneous. Just realize that's what it is. Extraneous solutions is you get answers, you just have to go back and check them. So that's kind of the big thing that you have to see here. All right, so let's give you some examples when we walk through this. Actually, we'll probably just do one, because once you see one, you kind of get the idea of what it's going to look like. Okay, so we'll go absolute value of 5x plus 2 equal to 7x plus 14. All right. Still going to do the same thing. We've got the absolute value by itself, so we're going to split it off to make it positive and negative. The one catch is that when you make this one negative, it's the negative of the whole thing, so you got to make both numbers. It's like distributed property negative. You got to change the sign of both numbers really when it comes off this part. And what really makes this one the extraneous solution part is that if it was just 5x plus 2 equal to 14, we'd be okay. But because of this x that's in this equation, that's the extra part that makes this thing extraneous, because we got a little bit something extra. So that's why we have the extraneous solutions when it comes off this one. All right, so with a negative number, we're going to change, basically do a distributive property with the negative, so we'll change both signs to get it here. And then once we've got the distributive property gone with parentheses, now we can just start moving some stuff around. I'm going to move this 7x to the left-hand side. And then we'll move this 2 over to the right-hand side. Okay, and then last answer, of course, we divide by the 12. All right, and again, it's okay to leave it improper, but you do have to simplify the answer, even if it is improper or proper, whatever the way it is. So for this one, we can divide them both by 4. So final answer we're looking for this one would be negative 4/3. Okay, right-hand side, same thing. We're going to just solve it. For this one, I'm going to get rid of the 5x, because if I do that, that way the x is still positive. Bless you. Okay, so moving the 5x to the right-hand side, subtracting on both sides, and then we'll move the 14 over to the left-hand side. We get negative 12 equal to 2x, and then divide both sides by 2, we get that x would equal negative 6. Okay, and for this part, didn't circle the answers, because once we get here, basically, that's the question we're going to ask is, do these things check out? If they do, it's great. If they don't, then they're not a solution when it comes off of it. Okay, so let's take this negative 6 and plug it back in up here for this one. So that would be 5 times negative 6 plus 2 equal to 7 times negative 6 plus 14. Okay, so taking the negative 6 and plugging it back in for x, And we work it out and see what's going to happen. Inside the absolute value, 5 times -6 is -30 plus 2, which is the absolute value of -28. And the absolute value of -28 is 28. Okay, and then our question mark is, okay, so we've got 28 on the left-hand side, plugging in the number. Do we get 28 on the right-hand side? We get -42 plus 14. That is a -28. 28 does not equal -28, so x equals -6. Doesn't work. Okay. If it doesn't check, that means that answer doesn't work. That's an extraneous solution. It's one of those where it looks like it's a good answer, but then when you actually check it, it doesn't really work for that part. Okay, now we do have to check the other one. Now, and for those of you that have a fraction phobia, you can use your calculator to get past the fraction phobia. So if we're going to plug in the -4/3, don't freak out on it too much, because we got 5 times -4/3 plus 2 equals 7 times -4/3 plus 14. Okay. And just use your calculator. When you got the 5 times -4/3 is 5, you got a parentheses, -4 divided by 3. And you basically you can use the division bar as a fraction as long as you put it in parentheses. Get that answer, add 2 to it. It's -4.6. So when you take the -4.6 you have over here, take the absolute value of it, that's going to make it positive. So that's 4.6 repeating. Okay, and then we do the same thing on the right-hand side. It's 7 times, so 7 parentheses, -4 divided by 3 plus 14. Also 4.6 repeating. So we've got the same two numbers, so this one checks.
So if they're both positive, you're not gonna say check.
Well, it doesn't, because we're doing absolute value, yes, pretty much when it comes off of it. Now, sometimes it may be that this one's like 28 equals 14, so you just got to check and make sure the numbers work out. But yeah, they both should be positive when it comes off of it. All right, so the only solution on this one is -4/3. That, since that was the only one that checked, then we'd be okay. The -6 didn't work, so we had to chunk it, had to get rid of it. And then one other little thing that might possibly, now sometimes you may do it and this answer checks and this answer checks, then they both check. If that's the case, you go ahead and list both answers. But if only one works, that's the case. If, and this is kind of a what if here, if neither answer checks, then you have no solution. Because that is a possibility that when you go back and check this one, it may be that neither answer works for this part of it. And if neither answer winds up checking for this thing, then you just, all right, nothing, doesn't matter what we do, we're never going to get an answer that's going to work on this thing. Okay, so with equations, it's if it doesn't say check for extraneous solutions, you don't have to worry about that. The answers you get is that. But if it says check for extraneous solutions, then you have to go back and double check those just to make sure. Because again, sometimes you get an answer that, yeah, you got an answer, but does it really make sense? And you're like, well, no, it really doesn't make sense when it comes off of it. All right, last thing we've got to do. Is absolute value inequalities. And these are one of those options where you have to just kind of look at it. And it's pretty much two types on this one. And again, it's one of those things where really you just have to look at it to know what it is that you're going to do when you get to these two types. If you have X, absolute value of X or absolute value of whatever it is that we're doing for this thing, and if it's less than some number, or again, less than or equal to some number, doesn't matter what it is. The way I kind of, and again, going back to when I was in y'all's shoes and trying to figure this thing out, what I finally figured out some time later on was that, again, you just have to look at it. Okay, that both of those are less than symbols. If it's less than, what I kind of figured out was that I started thinking, all right, that's less than, which means it should be an and statement. And if it's an and statement, when I get finished with it, it's going to be sandwiched between two numbers. Yeah, and it's really just that thought process of, okay, what am I doing? If it's X less than, then it's an and statement, which means I've got to have an answer that's going to be sandwiched between two numbers. If it's absolute value of X and it's greater than some number, again, it could be absolute value greater than or equal to some number. It's greater, right? And then again, in my mind, what I started thinking was, all right, if it's greater, really it's greater. So if it's an or statement, when we get finished with this thing, it should look kind of like oars on the boat. That when you get finished with this, you should have something to the left and something to the right, and you're going to have a gap in the middle. So it's going to be the exact opposite of this one. This one is everything in the middle of the two numbers. This one is everything on the outside of the two numbers that you get finished with. Okay, and again, everything on this part is just you look at it. So less than is an and statement. Greater is an or statement. All right, here we go. We'll do one example each because once you've seen one example, it's all, the same type thing, just a little different numbers. So let's do the absolute value of 3x minus 4 less than 8. All right. And just like when we're doing equations, you have to get the absolute value by itself. This one, the absolute value is already by itself, so it's not that big a deal. So what you're going to do is you're going to split this up between, you've got 3x minus 4 is less than 8. Now, you're also going to sandwich it between positive 8 and negative 8. And because it was sandwiched in there, this number is going to be, negative 8 is going to be less than this number, but at the same time, this number is going to be less than 8. So that's going to wind up making that this number is sandwiched in between the positive and negative of those two numbers. Right, now, and I don't think we solved one like this the other day because every and statement we had was broken up into two parts. If you have an and statement where it's all put together, you still pretend like it was just one part of it. If it was 3x minus 4 less than 8, you would add 4 to both sides. But now you have to do it to all three parts. So we're going to have negative 4 less than 3x, which is less than 12. And if you were going to solve this one, if it was 3x less than 12, you would divide both sides by 3. Well, now you're just dividing all three parts by 3. So we have negative 4/3 is less than x, which is less than 4.
And that's the answer.
And then that's your answer. There you go. And again, if it's an and statement, if it's less than, it's always going to be sandwiched between two numbers. because that would have been like the and statements we were doing yesterday. We said that when you get finished, in most normal cases, it was sandwiched between two numbers. And as long as we're doing absolute values with these, it's always a normal case. Well, I'll show you the one trick case in a little bit, but when we're doing these, it's always the same type of thing that's there. If you graphed it, it'd be the same thing. It'd be, you'd have a number here and a number here, and it'd be everything in between those 2 points. All right, let me show you a OR statement. Show you one of these, and that'll wrap us up. So let's go absolute value of 5x plus 10 minus 10 greater than or equal to 5. Okay, and again, for this one, before you do anything at all, you have to get the absolute value by itself. So get rid of that minus 10, make it a plus 10, move it over to the right-hand side. All right, now you've got the absolute value by itself, which again, still the same steps you do whether it's equations or inequalities. Now you can go ahead and split this thing up so we can make it so we've got the 5x plus 10 greater than or equal to the 15. And we said it's going to be an OR statement. And for this one, when you do the 5x plus 10, when you make this a negative 15, if you change this sign, you also have to change this sign. And some people are like, why didn't we do that back here? Well, we kind of did back here because we rewrote this one, it was all sandwiched together. If we had rewritten this one and we put in the negative 8 that was here, if we had done 3x minus 4 and negative 8, it would have been greater than. But then when we flipped this thing around to put the x in the middle, we actually did wind up kind of reversing that sign. So, we did it, but we didn't really see it because we knew we were going to sandwich it together based on the way this thing was. Once we're here, now you solve the two parts. Minus 10 minus 10. Divide both sides by 5, so that's x less than or equal to negative 5. And we got our OR statement. And then we'll solve the right-hand side. So 5x is greater than or equal to 5. So x is greater than or equal to 1. Okay. And again, with the OR statement, it will always say OR because it'll give you the two parts because the way this thing is split up. The AND statements, it's probably not going to be written with an AND because you're just going to sandwich it between these two numbers. Again, if you had to graph this one, we'd have everything less than negative 5 with a solid circle going that way and everything greater than 1 going that way. Okay. And again, the biggest thing with those is that when you do the absolute value inequalities, it's one of those where you just have to look at it. And once you look at it, it's going to tell you which one it's going to be. If it's less than, you're going to sandwich it between two numbers. If it's a greater than symbol, then it's always going to be an OR statement when it comes off of it. Oh, and then the one last little trick question thing that happens with this, and this is one that, again, it's still kind of that same way. If you have the absolute value of x greater than, let's say, negative 4, If you do the absolute value, now think about this one. If we take the absolute value of a number, we know it's going to be positive, correct? Every positive number is greater than -4, correct? So if you get absolute value of x greater than some number, it's a trick question because every positive number is greater than a negative number. So if you have one like this where you have absolute value of x greater than something like this is going to be all real numbers. Or maybe they're going to say that it's always true. You know, one of those kind of things. And if you kind of did it on the flip side of it, if you had an absolute value of x less than -6 or something like that, is there any positive number that's going to be less than a negative number? Well, no, because every positive number is greater than a negative number, right? So this would be one that this would be never true. So that's the trick question type stuff that you know may happen. And again, basically, here's what it comes down to: whether you're doing equations or inequalities, it's always a trick question. It's either always true or it's never true. You just got to sit down and think about which one it is and what it's going to be, and kind of get through that part.